One of the early applications of calculus was the calculation of values for functions like sine of x, ln of x, and e raised to x. So how are they solving these kinds of problems when they are not, when the calculator was not yet invented? So they are using Maclaurin series. And for this meeting, we will be discussing the process of Maclaurin series expansion to find the values of these functions. So the basic idea is to approximate the given function by a polynomial in such a way that the resulting error is within some specified tolerance. So what we are going to do, we will equate or approximate the function that we have. For example, you have a function f of x. We will approximate its value by a polynomial. So pag approximation natin, we will approximate it by a polynomial named as p of x. Your f of x is your original function, and your approximating polynomial is p of x. Taylor series and Maclaurin series are important classes of power series used to do this approximation of functions. Suppose we are interested in approximating a function f by a polynomial shown below. So, yung function natin, if we have the function of x, and we want to approximate its value using the polynomial of x, using this expression, c sub 0 plus c sub 1 times x plus a, this is c sub 2, sorry for that error, times x raised to 2. Notice that this is an example of a power series. Okay? Power series yan. Over an interval centered at x is equal to 0. Pag sinabing interval centered at x is equal to 0, we will evaluate them later on at x is equal to 0. P of x has n plus 1 coefficients. Notice here, if n is the number of, if you have a number n, for example, if n is equal to 2, kunwari wala itong values na yan, your polynomial, the polynomial of x, or px, will have n plus 1 coefficients because we start our coefficients with 0. So, disregarding these values, focusing on these parts, if n is equal to 2, your polynomial will have 3 coefficients, c sub 0, c sub 1, and c sub 2. We can impose n plus 1 conditions on this polynomial. Assume that the first n derivatives of x exist at x is equal to 0, and choose these n plus 1 conditions to be f of 0 is equal to p of 0, f prime of 0. Take note that f prime of 0 is the first derivative of f is equal to p prime of 0, and the p prime of 0 is the first derivative of p, and so on and so forth up to the nth derivative of each of these function and the polynomial of approximation. The value of px and its first n derivatives match the value of f of x and its first n derivatives at x is equal to 0. So what does this statement mean? We have a value for p of x. Or start with the function. You have the function of x as stated by f of x, and that is equal to p of x. We use equal na lang kasi approximately equal naman siya. So, for simplification, let's just take them as equal. But in reality, this is just an approximation. Okay? First n derivatives match the values of fx and its first n derivatives. So if we take the first derivative of the function, that is f of x, f prime of x, that is also equal to the first derivative of the function, first derivative of the polynomial of approximation. Same with the second derivative, the third derivative, and so on and so forth up to the nth derivative. Okay, pag sinabing ganito, this is not a power, this is the nth derivative kapag nilagyan natin ng parenthesis. Okay? So this is the implication of that statement. The value of p of x and its first n derivatives match the value of f of x and its first n derivatives at x is equal to 0. That is when you evaluate those expressions at x is equal to 0. So we have your approximating function. We take its first derivative, second derivative, third, up to the nth derivative. If we substitute x is equal to 0, we should evaluate it as at x is equal to 0. Notice that all of the expressions here with x multiplied by the constant will just be cancelled to 0. Because 0 multiplied by any number is 0. This will be 0. Same with here. May x ito, so makakancel. And here. And now we are left with p of 0 is equal to c sub 0. First derivative, second, third, up to the nth derivative evaluated at x is equal to 0. And that is equal to n times n minus 1, n minus 2, n minus 3, up to positive 1. And in this case, we can simplify this expression, itong mahabang product na yan, using what we call the factorial. Pag sinabing factorial, for example, yung 2 factorial, this is equal to 2 times 1. You should always end with 1. Because if you multiply this by 0, then this will become 0. That is not the case. It should be just up to 1. Okay? You are subtracting an increment of 1. So, kasi sinabing 3 factorial, this is equal to 3 times 2 times 1. Okay. So, ayun. N factorial c sub n. But, we have an assumption that the function is equal to the approximating polynomial when it is evaluated at x is equal to 0 and its succeeding derivatives. So if these values are known, we also know the value of the f of 0, first derivative of f of 0, and so on up to the nth derivative of the function evaluated at x is equal to 0. They are all equal. And from these equations, we can obtain the values of your constant. C sub 0 is equal to f of 0. C sub 1 is equal to f of 0. Notice that there is a magic na 1 factorial there because yung this one is similar to saying yung f of 0, c of 0 is divided by 0 factorial. Now, what is the value of 0 factorial? The value of 0 factorial is 1. That is a special case of a factorial. 0 factorial is equal to 1. Kaya nagkaroon ng 1 factorial doon kasi similar lang naman siya. 1 factorial is equal to 1 also. You do not subtract 1 from it because it is already the last term of your factorial. Okay, from p of x is equal to C0, or the approximating function. From the approximating function, if f can be differentiated n times at x is equal to 0, then we can define the nth Maclaurin polynomial for f about x is equal to 0 to be p sub n of x is equal to p f0, or this is equal to c sub 0. We substituted the value of your constant value dun sa ating approximating polynomial. So, substituting, we have this expression, and we call this the nth Maclaurin polynomial for f about x is equal to 0. Notice there is an n doon sa ating polynomial, meaning we are not taking the sum of this infinite series. We are just taking the first n sums. Okay? We are limiting it because we cannot take the sum of an infinite power series. Now, I have told you a while that we use Maclaurin series and also Taylor series in finding the values of certain functions. So let's try to demonstrate it using an example. So if you're asked to expand sine of x. Pwede ba yun, sir? Paano may expand yan? Simple na nga yung sine of x. I-calculator na lang natin. Pag tinanong tayo ng sine of 15 or sine of 10, kunwari, what is the value of sine of 10? Using your calculators. In degree mode, ha? Sine of 10 degrees.
0.1736.
1736, thank you. So that is the value of sine of 10 degrees. But how are we going to solve that value using Maclaurin series? Take note that during the early times, they don't have their calculators yet. So what they do to find the value of sine of 10, they will use Maclaurin series or Taylor series to find the approximate value of this one. Because sine of 10, meron pa yung kasunod na values, right? So, yun, ina-approximate lang natin. So, let us equate sine of x as our function, because that is what we are going to find. Okay, so that is our approximating function. So what we are going to do, let us find the derivatives of this function. That is the first step, to find the derivatives of this function. So, f prime of x is equal to, what is the derivative of sine of x? Cosine of x. Second derivative, the second derivative of sine of x, or the derivative of the first derivative, is equal to the second derivative. What is the derivative of cosine of x? Negative sine of x. Now, for the fourth derivative, di ba may negative tayo dito? So, kunwari negative 1. Oh. Now, you isolate the negative, and now you take the derivative of sine of x. The derivative of sine of x is cosine of x, right? So, cosine of x. You multiply it by negative 1, and you will obtain the third derivative. And that is equal to negative cosine of x. Okay? And the fourth derivative rather, of x, you isolate negative 1, and you take the derivative of cosine of x. The derivative of cosine of x is negative sine of x. Multiply negative 1 by negative sine of x. This is equal to sine of x. Okay? The fifth derivative is equal to cosine of x. The sixth derivative is equal to negative sine of x. The seventh derivative of x is equal to negative cosine of x. Notice we have a pattern here. We start with sine of x, cosine of x, negative sine, negative cosine, sine of x again. So, naturally, we are just repeating this pattern. Okay? So, may pattern yung mga yan. Now, let us now evaluate the function p of the function and its derivative at x is equal to 0. So at x is equal to 0, f of 0 is equal to sine of 0. Now, how does this make sense? During the early times, mathematicians do not have their calculators. How they did know the value of sine of 0? Sine is a trigonometric function. Tama ba? So, let's have a right triangle here. And let's name this angle x. Let's name the sides A, B, and the hypotenuse, let's name it as C. So in this case, how are you going to find the value of sine of x? So sine of x is equal to the opposite side, that is B, over the hypotenuse. And the angle is equal to 0. So if the angle is equal to 0, what will happen to our triangle? Essentially, it will become a line, right? Wherein your B is equal to 0. Because the angle between the hypotenuse and the adjacent side here is equal to 0. And what will happen there is that the side A will be equal to the hypotenuse C. So if you are looking for sine of 0, this will be equal to your B, or the opposite side, 0 divided by the hypotenuse C. And any number divided by, or 0 divided by any number will be equal to, what is the value? 0 divided by any number is equal to 0. So, f of 0 is equal to 0. F prime of 0, that is equal to cosine of 0. In this case, let's go back to the triangle. When you say cosine, this is equal to the adjacent side, A over the hypotenuse. If the angle is 0, angle between the two sides is 0, and then magiging pareha siya if you are going to form a triangle with the side 0, yung B. Sabi natin dito, A is equal to C. Essentially, the value of A is equal to C. Any number divided by its own value will be equal to 1. This is cosine of 0, sorry. This is 1. Okay? So, continuing, we have f double prime of 0. That is negative sine of x. Sine of x is 0. Sine of 0 is 0. Multiplied by negative 1 is 0. And we have the third derivative of 0 is equal to, what is that? Negative cosine. So cosine of 0 is 1 times negative. This will become negative 1. Continuing, we have your fourth derivative evaluated at x is equal to 0, this will be 0. Fifth derivative, positive 1. Sixth derivative, 0. And the seventh derivative is equal to negative 1. So, these are also equal to the approximating function, right? This is equal to p at 0. This is also equal to p prime of 0, p double prime of 0, p triple prime, fourth, fifth, the sixth derivative, and the seventh derivative, and so on and so forth. But these values is equal to c sub 0, right? Your p prime of 0 is equal to c sub 1. Your p double prime of 0 is equal to 2 factorial c sub 2. This one is 3 factorial c sub 3, 4 factorial c sub 4, 5 factorial c sub 5, 6 factorial c sub 6, and the last one, and so on and so forth. Now, since we know the value of this, we have equated these values, we can now solve for the values of your constants by equating 0, 1, 0, negative 1, 0, 1 to these values, yung p and its derivatives. So we can say that c sub 0 is equal to 0, c sub 1 is equal to 1, c sub 2 is equal to 0, because 0 divided by 2 factorial, kahit ano pa yung value ng factorial na yan, that will still become equal to 0. 0 divided by 2 factorial is equal to 0. C sub 3 is equal to negative 1 over 3 factorial. Correct? Cross multiplication. C sub 4 is equal to 0. C sub 5 is equal to 1 over 5 factorial. C sub 6 is equal to 0, and C sub 7 is equal to negative 1 over 7 factorial. Now that we have the values of your constants in our approximating function, we can now substitute this to find the expression or the nth Maclaurin polynomial at f is equal to, at f about x is equal to 0. So, we can already find your approximating function, and this is equal to, yung kanina, c sub 0 plus c sub 1 of x plus c sub 2 x squared plus c sub 3 x raised to 3, and so on. So this will be equal to c sub 0 is equal to 0. So c sub 2 is also 0. So essentially, matitira lang is yung mga odd coefficients. So we have here your c sub 1 is equal to 1. So 1 times x is x. Plus Your c sub 3 is negative. So that will become negative. X raised to 3 over 3 factorial plus x raised to 5 over 5 factorial minus x raised to 7 over 7 factorial. So this will become our approximating function now. So now we are going to evaluate your sine of 10 degrees. Correct? Kanina, ano yung value ng sine of 10 degrees natin? 0.1736. 0.1736. Take note that this is the value of our x. Now, using this Maclaurin polynomial, what is the value of sine of 10? So using the approximating function, what is its value when it is evaluated kapag 10 degrees? Try natin. This will be 10 minus 10 raised to 3 over 3 factorial plus 10 raised to 5 over 5 factorial minus 10 raised to 7 over 7 factorial. What is the value in this case? For this kind of problem, ang ginagawa ko dito, if I will input this in my calculator, I will utilize the variable x. Diba, you can input variables in your calculators, and you can just press calc to compute for many values of, or compute for the value of different values of x. Pwede nyo gamitin yung calc function. Negative
1307.
1307.
0.4603.
0.4603. Okay? That is wrong because your angle is in degrees. And recalling from the concepts of your calculus or analytic geometry or trigonometry rather, if your angle is outside a trigonometric function, for example, you have this expression, y is equal to sine of theta plus theta. If your, if your angle, in this case theta, is outside of a trigonometric function, then this should be converted into its radian degrees before computing, if your calculator is in degree mode. Okay? If the angle is outside a trigonometric function, when you say trigonometric function, those are your sine, cosine, tangent, and so on and so forth. Because a trigonometric function cannot stand alone. Walang value yung tangent lang. Dapat meron siyang kasamang angle. And if the angle is outside a trigonometric function, you should first convert it into its radian degrees. Now, in this case, kapag ito naman, if your angle is inside a trigonometric function, in this case, the sine, then this should be in degrees. Sorry, this is radian units. This is radian units. That is one common error. If your angle is outside a trigonometric function, similar with our example here, wala naman tayong trigonometric function sa ating mga values, then that should be first converted into its radian units. Dito naging tama siya, sine of 10 degrees, because that is inside a trigonometric function, in this case sine. So, ang value niya is 1.1736. But, in our approximating function, wala tayong trigonometric function. So let us first convert 10 degrees into its corresponding radian units. So 360 degrees is equal to 2 pi of a radian. What is this equal to? What I do here is I isolate yung pi para hindi siya maging decimal, para maging fraction pa rin. 10 degrees times 2 divided by 360 is equal to 1 over 18. So that is equal to, multiplied by pi over 18 radian. So we can now use this to solve for the value of our function using our approximating function. So p sub n evaluated at pi over 18 is now equal to pi over 18 minus pi over 18 quantity raised to 3 factorial plus pi over 18 raised to 5 over 5 factorial minus pi over 18 raised to 7 over 7 factorial. Now what is the value of this expression? 0.1736. In this case, same yung tama yung approximating function natin. Okay? I hope that is clear. But hindi natin ini-include yung mga succeeding items. If you will notice, kapag in-include mo yan, it will have a very minimal effect on the value of your polynomial function. Kasi yung mga values sa dulo is nandito na siya. It will affect the succeeding decimals here. So, hindi na siya masyadong ganong significant. Unless otherwise you want to have 10 significant figures, then you need to find those values. Okay? But in this case, we are only looking for the first n. In this case, 7, yung ginamit natin na n. The first 7 sum of your infinite power series. Okay? So that is how you apply the Maclaurin series in finding the values of certain functions. Now, what I want you to do is to try using Maclaurin series in solving for the value of cosine of x. Tapos mag-try kayo ng iba't ibang angles kung magiging parehas sila. Why am I doing this? Because essentially, one way to know, to determine if you have really learned something, is that if you are able to do it yourself.